the prevalence of life in the galaxy. If you can quantify that somehow, I don't know how to quantify it just yet, but imagine that's a quantifiable entity. The prevalence of life that we presume to be out there, the stock in the prevalence of life has gone up. For me, the best argument for upping that stock value is the following. When you took biology class and you learned the age of the Earth 4.5 billion years ago, and then you look at the earliest evidence for life, fossil evidence of life on Earth, then you get about 3.5 billion years. Subtract those two numbers, get the difference between those two numbers, and that's the time clock from beginning to the first evidence for life. So that was about 1 billion years out of the 4.5 billion years that Earth has been here. So that's pretty quick. It happened in like the first 20% of the life of the planet. Now, we have found fossil evidence of life farther back in time than 3.5 billion years. It now goes back to 3.8. There's some evidence it might even reach 3.9. So we have shrunken the time available for life to have formed on this Earth. That makes it more likely. If the faster life kicks in from a pool of just random chemicals, not random, they're the chemicals of the universe, the faster that happens, the more confidence I have that life is something that would happen just given the right soup and soup starter. Now, we then learned when computers got good, better than they once were, that the early solar system didn't just simply make the sun and the planets. There was debris all scattered in interplanetary space. And that debris slowly got vacuumed up by the gravity of the respective planets. That would not have been a pleasant occasion on the surface of those planets, because to vacuum it up simply means you're getting slammed by the kind of asteroid that took out the dinosaurs, except you're getting that monthly. And you can calculate what the temperature of Earth's surface would have been. And it would have been higher than what would allow complex molecules to form. Because at high temperatures, you break apart molecules. What our computer models show is that this period of bombardment, period of heavy bombardment is the official phrasing, lasted 600 million years. So it's not fair to start the life clock at 4.5 billion years ago, because life had no chance of forming when the surface of the Earth is molten. Wait for things to cool down. When there's a chance that carbon can run its magic, then you start the clock. Now you're going from 4 billion years ago into 3.8 billion years, and you have pinched down to 200 million years, down from 1 billion years that was imagined just a generation ago. And that is further evidence that practically the earliest life could have formed, it did. So just because we find it hard to do in the laboratory doesn't mean nature found it hard to do as well. And the idea that it's hard for nature to do because we can't figure out how to do it yet, that itself is an inexcusable expression of human ego. It may be that intelligence is rare in the cosmos, intelligence as we have defined it. Because if you look at the fossil record, you look at the portfolio of life that has lived and thrived on Earth, there are a lot of features of life that many different species have in common. For example, locomotion is a pretty common talent. In fact, we have creatures on Earth with no arms and no legs, and they still manage to move. We call them snakes. So locomotion, they figured out how to move even though they don't have arms and legs. But what we have is evidence of features in life that apparently are really good for survival. The capacity to receive information at a distance. Smell, hearing, sight. Sight is a very common feature in animals. In fact, there are certain expressions of sight that happen independently of each other. That's how valuable this was as a tool for survival. The fly eye has nothing whatever in common with the vertebrate eye, itself having nothing whatever in common with the octopus eye. Yet they are all eyes and they all see. Let's look at intelligence. Intelligence, as we have defined it, has shown up nowhere in the fossil record, which tells me that intelligence can't be all that important for survival. Otherwise, it would have been there in the fossil records multiple times throughout life, but it's not. In fact, you can continue this to its extreme and say it may be that intelligence is just the right thing to have to render yourself extinct. So let me remind people about the Fermi paradox. Enrico Fermi, he did an actual calculation on the back of an envelope, as we call it. So it wasn't some grand chalkboard calculation, just he made some estimates. And he said, all right, I know the speed of light is fast, but let's say they have a civilization that can go maybe 1/5 the speed of light, 10% the speed of light. How long would it take you to cross the galaxy? The galaxy is 100,000 light years across. So if you go 10% the speed of light, it'll take you 10 times that. Sounds long, but hang on a minute. That's not where you're first going to go. You're going to go from our star system to the nearby star system. And then you're going to pitch tent, grow civilization, and now you're going to launch again. But now you're not just going to go to one more, you're going to go to two more. And then each of those two will go to two more each. So that goes to 4, to 8, to 16. And so your civilization spreads out rapidly, exponentially. All right, and you'll get to nearby stars in 10, 20, 30, 50 years, and you just have a new civilization there, and they send out 2 more probes. What he concluded was, if any sensible assumptions you make, the whole galaxy and all available planets can be colonized within a few million years. That is short compared with the lifetime of the galaxy. So suppose you had an advanced civilization that started 5 billion years ago, at the birth of the sun, a whole other star that's been around. Then they could be all over the galaxy and we don't see them. So then everyone is saying, well, how come we don't see them? Yes, one of the reasons are they could be just like us and destroy their own planet. They're so smart, they figured out how to destroy themselves. That's one example. Another one is space travel is just too hard. Another one, this is my favorite of them, is that whatever genetic profile, whether or not they use genes, whatever is in you that wants you to colonize planets, if that's driving your entire civilization, and you go this way and you get 2 planets and you get 2 planets, there'll come a time where we both want the same planet. If that's the case, then the whole system will implode, which kind of happened with European colonists. England had colonies, France had colonies, Spain had colonies, Portugal had colonies, the Dutch had colonies, and you reach a point where there's not enough land to go around and they fight each other for control of that land. So we saw that play out on Earth's surface, where if you have this expansionist mentality. So it could be that whatever is the urge that would want to make that happen in the first place has the seeds of its own unraveling. I would say that if there weren't life, it would be astonishing. Given how common our ingredients are and how quickly life took place here, and how many planets we know are orbiting host stars. It would be astonishing if that were the case. It could be out there. There's no evidence that would convince an authentic skeptic that we've been visited. These fuzzy, monochromatic tic-tacs that show up on the Navy restricted airspace in our own atmosphere. By the way, you've seen the high-resolution images from a telescope we parked 1 million miles from Earth, called the James Webb Space Telescope, looking at the edge of the universe. And the best you have of visiting aliens in our own atmosphere is a fuzzy tic-tac? You got to do better than that if you're going to convince an astrophysicist.
UFO. First, remember what the U stands for in UFO. Now, there's a fascinating frailty of the human mind that psychologists know all about, and it's called argument from ignorance. And this is how it goes. Somebody sees lights flashing in the sky. They've never seen it before. They don't understand what it is. They say, a UFO. The U stands for unidentified. So they say, I don't know what it is. It must be aliens from outer space visiting from another planet. Well, if you don't know what it is, that's where your conversation should stop. That's what argument from ignorance is. It's common. I'm not blaming anybody. Psychologists know all about it. And it may relate to our burning need to have to know stuff because we're uncomfortable steeped in ignorance. You can't be a scientist if you're uncomfortable with ignorance, because we live at the boundary between what is known and unknown in the universe.
So look at beavers. Right? Beavers are mammals. They're large brain, like relative to other branches on the tree of life. And they fully exploit the resources in their environment. Oh, there's a tree. I'm going to use that tree to dam this river, and I'm going to make an underground den. Are we any different from that? We use trees. Well, first we use grass to make huts. That was available. Then we use trees. That's pretty convenient. Then we found metal. Oh my gosh, let's use that. Okay. And then we learned how to make alloys. Let's do that. And then we learned chemistry. Let's do that. So, yes, it takes thresholds of intelligence to exploit your environment even more. But the simple act of exploiting an environment is not unique to being human. The Romans were no less smart than anyone who followed them. All right. Smart in terms of what their brain could figure out, but they didn't have alien communication technologies. They didn't have radio telescopes. They didn't go into space. So imagine the Roman Empire and aliens are waiting for a return signal back through space and no return signals.